going to start very well. All right, can we start? Hola, buenos dias.
Muy bien, muy bien.
Nice to have you on board. Our topic today is AI. We have a dedicated team within Quantum for especially that topic. I'm more than happy to have you here, both of you. And we have Leon with us today, and we have Juan with us today, and both of them will introduce them very shortly. Leon, I will give you the first introduction round and then just talk about you, how long you're within Quantum, and what are you doing exactly?
Thanks, Luca, for the introduction. So more than happy to be with you here today, also with Juan on my side. You said it, I am part of the AI team, or I'm software engineer here, and I'm leading the team. And we're currently a team of 10 people, and working on various AI topics to provide aerial intelligence. I joined Quantum about a year ago when the team was much smaller. So one of my main tasks is here building the team, growing the team, and to attract the best talent in the industry and make them join us.
That's great. So how big was the team when you joined?
It was half the size.
So what does it mean? How
Five people.
5 people, so now we're 10.
Exactly.
Crazy. And we are growing, right?
We are growing.
We are aiming for more people.
Absolutely. So there will be more headcount in 2025, and I'm more than excited to bring new people to the team. There will be new topics. Juan will talk about it later,
Yeah.
I guess. We're very exciting times. So I'm very excited, actually.
So that's great to hear. So for everyone who's watching now and can't wait to apply, this is the link here.
This is the link.
You can apply here. And then we just, continue with Juan. Juan, nice to have you. Short introduction. What are you doing?
Yeah, so I also joined like a little bit more than 1 year ago. At that point, we were 3. And now, it grew a lot. And I've seen the development of the whole product from the beginning, which was quite exciting. I was also involved from the low-level stuff to high-level applications like object detection or object tracking. And now I'm moving towards making it work with multiple drones. So bring all the knowledge that we collect from the AI and make it autonomous and multi-agent so that it's easier for the users.
That sounds very interesting. I think we'll dive into that soon. You brought some nice gadgets with you today. Do you want to tell us a bit about that? I mean, I know that a bit, but I think you can.
Yeah, let's talk about it a little bit in more detail.
Maybe hold it in the camera and then we can see it.
Yeah, I hope that you can see it, guys. What you can see here is our latest iteration of what we call Receptor AI. So this is basically the nose of our vector drone. It incorporates all of the important components we are working on as a team. So we have onboard compute with an NVIDIA Jetson that sits underneath this cooling device here. And you can clearly see the gimbal here. It's a 360 gimbal where we can get EO and IR images. And we have an additional IR camera for navigation topics. I think we'll come to that also. But this is basically it. We're mainly working on this device. So it has everything what we need. And you can also see we also brought like the actual PCB board, which is sitting underneath here. So just to give you a clear picture, that is the small compute unit. I guess if you're familiar with embedded devices, you've seen these probably. So it's an NVIDIA Jetson and our own PCB board, and we for sure have some active cooling here to not burn the office.
So you talked a bit about the product. What can the customer expect when using the new payload? What are processes that enhances now? What are the improvements?
Absolutely. So I will mainly talk about three main important topics, and I leave out one for Juan since that is our newest topic here. But the team is mainly working on object detection, object tracking, and the third very important component is visual navigation. So starting with the first one, object detection, I guess that is almost a commodity in the AI space. So it's about detecting different objects of interest. For us in the governmental space, it's, for example, different vehicles that we need to detect, people for sure, and from the object tracking side, we are interested in tracking static objects and also moving objects. I think that is also something that is very widely spread as a topic and well understood. And the third component is considerably harder because here we're talking about flying in GNSS denied scenarios, so where we have no GPS signal. And we are working on visual navigation to make our drones being autonomous for the missions that we fly. And here we clearly need to put in much more effort. It's a very hard task actually to fly in rough environments under very different conditions and make sure that the drone can always operate and fulfill its mission. And for that, we use visual components and visual navigation and algorithms to make this happen.
All right. So when speaking about rough environments, we have a big customer in Ukraine. We are flying in a scenario which is very rough. Electronic warfare is the key word there. Having no GPS at all, constant jamming environments. So what are the key aspects we have to consider when developing our new products, our new AI? What have you learned about the past in the past months?
I mean, you said it clearly. So Ukraine is currently one of the most challenging environments where you can operate UAVs, I guess, worldwide because of heavy jamming conditions, both on the GPS signal, which leads to what we call GNSS denied flights, and also on the data link. So don't have to forget about this. It's important. And in these scenarios, we might lose completely the connection to the drone. So the operator has no idea where it might be. And these scenarios are especially challenging. And when we fly in these situations, we need to make sure that the drone can continue its mission. And for that, we rely on visual sensors. So you've seen the IR camera, for example, to also being able to fly nightly missions and to always have a reliable position estimate for the drone at all time. Mm. That is really hard, to be honest, but also very interesting to work on.
That's the thing, I guess. So you're developing everything in-house here.
Exactly.
How do you test this? I mean, this is a lot of features, but how do you test them?
Good question. So, we have amazing testing facilities here. So, my team and I, we usually go out and fly our drones like at least once a week. That is fantastic. So you're not only sitting in the office doing coding, but you're also you also face the challenge of being the operator and see your things in action. To test under realistic conditions, it's not possible here in Germany. That is clear. But we have the great situation that part of my team is also in Ukraine, and there we can really test under these harsh environments directly.
All right, and you see the benefits, I think, on a daily scale, right?
Absolutely.
Okay. All right, Juan, we've spoken about flying in GNSS denied environments, but also a big topic is flying in swarming situations. Can you guide us a bit through this topic?
Yeah, so basically the AI part enables the swarming. So basically you need to be autonomous in order to be able to collaborate with the others, because the user cannot control several drones at the same time. So the final goal of the swarming, it's probably making the system completely autonomous and able to explore larger areas in less time. And usually when you're exploring, most of the places don't have anything interesting. So how it works now is you have to watch the video and try to identify it yourself. And the idea is to use all the AI capabilities in parallel in several areas at the same time. And then the AI will filter and analyze the data on board and just send the relevant information to the user. So that's the main goal of the swarming.
Okay, so we're having the current state. What we're actually doing, flying multiple drones, but having to watch every video right now and make analysis on it. So what is the future scenario? What are we aiming for? What's within next year? What's within the 5-year framework?
Yeah, so how I envision the product is the user could just put 4, 5, or 6 drones on the ground, select what does he want to do in a high level, like explore this area or explore all my area around, and just forget about it and just get notified when something happens or something is detected. And ideally, they would be able to do it without satellite navigation and also without direct communication with the base station. So only communicate the stuff that it's important.
What excites you the most when working within these topics?
Oh, very good question. So I think, first of all, and I guess I can speak for both of us, it's super interesting engineering tasks. So I guess that is what we are mostly fascinated about. Yes, we are a team working on artificial intelligence, but it is much more than that. So here you are not only tasked to fine-tune parameters for a model, but it is much, much more. So we are actually responsible for this whole product, meaning software-wise, but we also need to work on much things that are low level on integrating sensors. So really building an end-to-end product that is fascinating, I guess, for most of the people joining my team. And I guess that's also the most fascinating point for Juan, isn't it?
Yeah, I mean, I like to work on many topics, and
Same.
basically here there is a lot of work to do on every level. So, for example, I was working on modifying the operating system, and then the week after, I was working on integrating some models or any other application. And that's really cool because it allows you to, learn from a lot of fields. It's not easy to find that out there in other companies.
So what is something you're working on right now? What can we see right now? What's the actual status we're having right now? And what are you aiming for within the next months?
So I briefly talked about the 3 topics. So object detection, tracking, and navigation. And currently for us, it's clearly navigation. So visual navigation is really the hot topic at the moment, because it will enable us to fly in these very harsh environments, especially in Ukraine. And also we are providing like flyaways, so the customer really can rely on getting the drone back after its mission, apart from losing signal, apart from flying in fully GNSS denied environments. So that is clearly one of our main focus points currently.
So how does this work?
Oh, that is a fascinating topic on its own. So let's see how deep we can dive into it.
Podcast.
We need another podcast for that.
So brief summary.
Brief summary. So actually there are 2 components. So we clearly distinguish between getting a relative position and an absolute position of the drone. So there are 2 different approaches, I would say. The one where we talk about absolute positioning is clearly we try to get an image of the current landscape we are flying over and compare that to map data to get the latitude, longitude position of the drone. And then there is another component where we try to find in real time the trajectory of the drone in order to ramp up the position estimate that also other teams are working on here, and to improve this accuracy of the relative position at all time. So clearly two algorithms we are working on. Under the hood, there are similarities between these, but this is to give it in a nutshell. But for sure, we can talk about it in much more detail.
Let's do a follow-up. I've talked about that in another episode. I think it was in corporate culture. Where we had like, okay, in Amazon, there's a Prime version. So you have a basic podcast episode. And then if you pay for the Prime, you get the Prime edition, right? So that's what we do over here as well.
We're trying that as well.
Yeah, it's the same. I said, if you're an applicant and if you have successfully applied and you work with it, then you see it.
Get the
all right. What are the typical use cases we see within the AI?
So currently, I would say clearly to provide aerial intelligence for a single operator, and by providing these capabilities, I already talked about them, and I guess. For the future, it's clearly operating our family of systems and swarms. So clearly you have fully autonomous missions, fully autonomous systems, and we try to build this stack for our whole family of products.
Okay, so I mean, we serve for two applications, two sectors, in governmental and the commercial sector. Sorry. In the commercial sector, we're having a lot of customers in agriculture and mining and all of that. What is the biggest enhancement for them? So what is the use case they can really use the AI gnosis in the future?
On the commercial side.
On the commercial
side.
On
the commercial side, so it's mainly topics. Let's think about one use case. It's wildfire detection, right? So getting accurate information about wildfires. We can also imagine scenarios to count animals in very remote areas, to have a look on deforestation, for example. That is all of these topics where you have to cover large areas. And also for that, I mean, swarms could also be very, very interesting to cover even larger areas. But these are the main use cases, I would say.
Yeah, for example, in the forest fire case, I've been working on that also in the past. You could use several drones to monitor the current state of the fire, and you can get the boundaries of the wildfire, and you can feed that information to a wildfire simulator to constantly predict where the fire is going to be and potentially save lives. So basically, fires are very hard to predict, and there's a lot of factors that influence there. And if you have a current accurate state of how it's evolving, you can react better on that.
So what is the final product you envision? I mean, I think it's a question that you can't answer because the topic will develop so fast.
So I guess Juan previously already touched this topic. So when we see this as a layered approach, so we are building like base capabilities in terms of AI, meaning object detection, object tracking, visual navigation. These need to be very robust components. And then we can take this to the next level and build what the AI community these days refer to as agents, and have swarming agents, for example, that take these capabilities and do something else with it. But I guess in terms of swarming, you clearly have one here as an expert sitting.
So give me a brief explanation then.
Yeah, so I mean, I mentioned a little bit before. So, but for example, to put a basic use case, you want to monitor a border. That's a huge area, and it's impossible to have someone watching at the videos all the time. So in this case, you could potentially select the whole border, launch as many drones as you want, and then have them analyze the data. So we have thermal sensors, visual sensors, and potentially we can incorporate some other sensors. And the AI part would be to fuse all the information, process it, and the agents will decide what to do with this information. So, for example, if you detect a threat, you can make the drones to react to this information online, and basically, I don't know, have two of them looking at the same to improve the confidence you have over your automatic detection. And when you're completely sure that you have it, if you have direct communication, you can send it. But if not, you can send another drone with this information towards the base, and then deliver the information. So also in border control, there could be GNSS denied situations or where the data link is jammed. And therefore you need to take all this stuff into account.
So we've also spoken with another team about the drone port applications and having the next automation level and having multiple drone ports maybe on a border and having our UAVs then deployed, and then it's a fully autonomous situation, right? You don't have the human in the loop anymore, I would say. So it's deployed, launched automatically, it's recovered automatically. So you just have the data in the future.
Exactly.
Yeah.
So it sounds really interesting. So what do you say, how is the situation developing then? What is the, in 2 years from now, what is the situation for an operator then, seeing having our drones and making a border security mission?
So yeah, as said, I mean, currently it is a single operator use. So the operator takes out the drone, flies its mission, and then gather all the information. And we envision a future where we can easily deploy multiple systems, whether they be within static drone ports or even moving drone ports, like putting these on vehicles, for example, to make them even more flexible. And then it's more of a case like the operator wants to get aerial intelligence for a certain area of interest. And then our system will decide, okay, what is the best strategy actually to get all of these informations that we might need in order to provide aerial intelligence. So it might be that you send a single drone. It might be that you send a swarm of drones because it's too large. And all of these components will come together. It's also very fascinating to be here currently, because we are not only working on one drone, but we are working on multiple drones. Like, we have a family of systems. So you have seen the nose of the Vector, but it's also the Twister that comes into play, and in the future also the Reliant as another platform to provide more distance, greater range, and which will enable us to fly other scenarios.
So I'm now talking about, or in the perspective of an operator. So I'm now
An engineer.
no, a fireman, I would say,
Okay.
and operating today.
Yeah.
Having my drones, and we spoke about that. So we deploy the drone, we do the mission, and then I look at the screen, and with the help of AI, I get interesting objects for me. Speaking about in 3 years, we have multiple drones, we have swarming, everything is fully autonomous. What are the deciding factors for a fireman like me? What can AI show me? What's interesting for me in this situation? So how do you decide that in the background?
In which sense?
I mean, the code behind it decide then what an object is interesting, right?
Exactly.
So how is that going to be decided? How can I get this information then?
So, for example, in the case of forest fires, if you want to use it for prevention, let's say, or for an early alert system, it's basically, I mean, we have thermal cameras, so sometimes you can even detect already the fire through the thermal camera, but if not, you would see some smoke. So that's also the current state of the art algorithms can detect, and therefore they can expect that they deploy the drone, and if there is any hotspot or smoke or wherever, he will get informed. And yeah, with the swarming, it's more like I have this huge forest to monitor. I just press a button, and then ideally they could be 24 hours monitoring. So if you have a drone port that it's able to take them, exchange batteries, and launch them again, it could be a completely continuous operation, and that you can also move from one forest to another and deploy it in different areas.
So I have multiple deciding parameters, which sender then decides on. Is that something what you right now do manually? So like, okay, the UAV or the sensor has to look at a dedicated parameter. Like, I don't know, for a border control to see if there's a foreign object coming. So, but what is there any change in the future? Like, you don't even have to give the parameters away. So the drone itself selects parameters that could be interesting for you that you're not even thinking of.
Exactly. I mean, that is clearly the mission. So right now we try to gather interesting points or points of interest for the operator. Yeah, it could be wildfire detection, could also be vehicles, could be any object of interest, depending on your use case and your scenario. But clearly in the future, if we operate on certain missions, the drone should decide by itself to gather more information on specific scenes, on specific scenarios that we face, and also the communication between our systems will then be fluent, such that these information can be exchanged and that there will be a constant decision about, okay, what is the strategy to best fulfill the mission for the operator, because the final result is still giving information to a human, like providing information in a condensed format, such that a human can decide on next steps and next missions, basically.
I think that's very interesting. Also in the fire use case, to not only see a hotspot when some flames arises, but the situation before. So what could lead to a hotspot,
exactly.
Right? So that's, I think, the interesting point where we're heading to, and I think it will be interesting to see, or having this talk again in maybe 2 years from now. What are we talking then about, right? So I think
absolutely
this could be a really interesting topic. How do you achieve all these goals?
Magic, black magic, as some people call it. No, I mean, we are working on AI algorithms, right? So object detection, object tracking is something that I said is more or less commodity, I would say. It's well understood. Visual navigation is still more interesting and much more difficult, especially for a flying drone like we have one here. And then for sure there is these agents, right? So getting swarms to fly and do missions together, that is clearly a fascinating challenge that we are going to face here. It's work on individual algorithms. It's work on the systems that surround it. So it's basically a lot of software engineering, which is the fun part.
Yeah, same for you, I would say, right?
Yeah, I mean, in the end, it's taking state-of-the-art algorithms and optimizing and adapting for our needs. So, for example, for swarming, we can use a lot of knowledge already from game development. So the AI machine-controlled agents in the game, they're also moving autonomously and cooperating with each other. So we took some ideas from there also. And on the AI topics, we need to be constantly reading papers and finding new algorithms and basically do applied science to our problem.
So it's a life
really
full of
cool.
learning, I would say.
Absolutely, it's constant learning.
You never stop learning.
That's the fascinating part, I would say.
That's cool.
And you need to be like at the leading edge, I would say, because whenever there is a new possibility, a new algorithm that might perform better, why not take it?
Yeah.
And then for us, it's the great challenge, since we are doing embedded inference here. We need to operate everything on this Jetson device, so it has to be highly optimized. So it's a limited compute. So we are not dealing with a huge rack of NVIDIA GPUs where we have infinite amount of compute, infinite amount of energy. So it's a restricted set of things we have to work on, and that makes it even more fascinating, because you not only try to think about the best algorithm, but you also need to think about how can we make it run in the best possible manner to be as efficient as possible.
Sounds like a big task.
It is.
But I also see the exciting part in it and your joy about it. That's great to hear. Speaking about the topic, the development and the hard to achieve milestones, we need future engineers, future crew employees for your team. What do you want to tell them on their way to apply? What is their what do you give on their way for an application, and what do you want from them? What do you want to challenge them? What do you want for your team?
So you mean in terms of an ideal candidate?
Yes.
Hard to answer. So yeah, we are looking at people who are first of all not afraid of touching hardware. So it's not software only. That is important. And then it is broad software engineering with a heavy focus on AI. So it's not that you need to bring very high specific knowledge about tuning a single algorithm. It is much more. We will ask you to take an algorithm and to make it fit such that it can run on our drones and in our whole ecosystem. So you need to bring actually very broad knowledge from systems engineering up to the application layer of fine-tuning an algorithm. What would you say?
Yeah, I would say the same.
So maybe talking about like technology and languages, I think it's not a surprise to say we are mostly dealing with C++ to make things run fast. But for sure, we have also other technologies under the hood.
Okay.
But that is a core component.
Sounds good. Juan, what has been your highlight within this year? Tough question,
so
right?
The main highlight is that we started with the swarming topic, which is also my expertise field, and that's very exciting. So we are building everything from scratch. I can make the decisions on how to do it and so on. That's pretty good. And yeah, I mean, we have achieved a lot of things. Also, one other exciting thing is that we made recently a lot of progress on global navigation, like global positioning with visual information. That was also quite impressive. So yeah, we have a really good team actually.
I would also say so,
yeah. We do a lot of things.
So 2 happy team members here. Yeah. What has been your highlight so far?
Actually, I could speak about a lot of topics, but we clearly achieved far better object tracking over the year. Now, Juan already mentioned current focus is on visual navigation, and we are very close to ship this to Ukraine and to support the missions there, which will be probably the last highlight then of this year. But I guess in general, the team can be super proud of what we achieved this year. There are for sure also a lot of components that you do not directly see as an operator, right? So it's if we can ship our system and it just works, it is the greatest achievement that we can have as a team. And for sure there will be individual components, but it's also a lot about things, gluing things together and make things work in the most efficient manner. And that is clearly an incredible achievement of the whole team.
So you have a strong team.
Absolutely. I mean, we have like very experienced engineers, but also we are having junior engineers as team members and also working students. And we are looking for the whole spectrum of engineers, right? And that makes the team also very special. So
who's organizing your team events then?
Good question. I think by now it was actually that is a hard question because we should do a team event again.
See, I got you there. So what was the last one?
The last one is can't remember, but I would answer it like this. So we were so busy with work that there was clearly no time to do a team event. No, just joking. But you're right. You got me. We need to organize a new event, maybe before the end of the year. And yeah, clearly it is probably my task as a team lead to do
some celebration of all the achievements you made.
Yeah, I think the problem is that the team grew so much that
that's true.
It's impossible to find a time where we all can go. So
that's true. I mean, people go to demonstrate, not demonstration, but go to events and demos. It's kind of hard to find a date where everyone is here. We clearly have an office culture. That is amazing. So as said, we're going out for flight tests regularly. But finding a date is quite a challenge. And then also deciding what to do is another one.
So now you got another challenge. Yeah. Oh man, what did I do? Do you have any dogs within your team?
No.
We're missing one.
We are missing one.
See, so for future applicants, bring your dog.
Yeah, bring your dog. Bring your dog.
It's
dog
even
friendly.
More important than C++ is your dog.
So maybe some more competencies to bring into the team.
Yeah.
You never know.
I think we all would love to see one.
Yeah.
But I can also tell you we are very happy because there are so many dog owners here. So there are plenty of dogs coming by the office.
You just steal the dogs into your office, yeah? All right.
Exactly.
Got it. All right, I think that was a great talk. I think we could make so many deep dives into.
We should.
Into the talk. Yeah, okay. But then we're sitting. I think we're sitting here within the next 5 hours or even 5 days.
Maybe not 5 hours or 5 days, but.
Do you want to have one more?
Maybe there is an opportunity to have some deep tech talk in the future. Let's see.
I would be more than happy to do that with you. I think it was very, very exciting and great to have both of you here. I think I got a very good overview about where we're standing and where we want to aim for. And I can't wait to hear all of the improvements we can report within the next year, maybe within 2 years. And then I think we will have another talk. And I'm very looking forward to these talks.
Thanks, Luca, for having us.
Thanks, guys.
Thank you.